this was a little warm-up to try to flex your muscles with factoring. So last week on Friday, stand by. Technical difficulties. Last week on Friday, I gave you problems like 3 times 2x plus 1, I don't know. And we were multiplying, and I showed you the distributive property where you split the first set up, and then you repeat the second set, and that made it easier to multiply when you have a binomial times a trinomial. And then you multiplied it all through, so this was 2x squared plus x minus 6x minus 3. Then you have like terms here. There's a reason I'm showing you this. Okay, so this was last week, right? And that was when we were, man, this takes count. When we were multiplying, yes? Mm-hmm. Okay, guess what? Reverse. Today, and we are factoring. Look at the connection though. So when I throw a factoring problem at you, please don't think of it as a totally different type of math. It is the same math that you already know how to do in this direction, multiplying. We're now going in reverse, which means we're starting with 3 terms, sometimes 2, we'll get there. We're starting with 3 terms. We have to rewrite the 3 terms in a manner that splits that middle term into 2 common terms that when added back together would give it to you, right? You see that? Positive x minus 6x is negative 5x. So we're going to have to, and I'm going to show you how, come up with the 2 numbers that will yield the middle term, write the 2 numbers, and then we will do what's called factoring by grouping, which is exactly why I want you multiplying in this direction, because when you are factoring by grouping, you are literally going in the reverse direction, step by step. You say to yourself here, what is the GCF? X. So you pull the GCF out to the front, and then you divide it by that GCF, and you write what's left. Then you repeat, what's the GCF? Negative 3. You pull the GCF out right here, and then you write what's left when you divide each of these by negative 3, and then here's your checkpoint. This better do what? It better match, which is why I teach the split repeat method, because it matches when you're multiplying. When you're factoring, it better match. Because now you have lots going on here. Focus. You have this mess minus this mess, right? Yes? What do they have in common? The green. You see it? So you pull that GCF out, and what's left? X minus 3. So that's the plan. I just gave you like an entire example of what we're doing today. Now there's some special cases, and I'm going to show them to you.
How do you find the X and negative?
I got you. Don't worry. I'm going to show you how to find it. Okay. That was an example. Let's see if you got these. I'm going to go to this one first. Number 2, and this would be a good time to take a couple of notes on here. Number 2, what do you notice about every one of these terms? They have a multiple of 3 in them. I want you to take some notes and say, factor GCF out first. factoring polynomials, you always, always, always check for an initial GCF, because if there is one and you do pull it to the front, factor it out, now what's left is a lot smaller and more manageable. So I'm going to divide every single thing by 3. Now the 3 does not just disappear. If you drop the 3 completely, you have the wrong answer. The 3 is still there. It's just in the front, right? See how much smaller the polynomial is now? Okay, now I'm going to show you how to factor a trinomial, and we're going to take a couple of notes on this. Here is how I teach students to factor trinomials. The first part of it is unorganized, because it's like a little side blurb. You're over here playing with numbers, guess and check, trying to figure out what numbers work. This is what we're trying to find out right here. We're trying to figure out these two. Okay, so there is a method called factoring by the fraction method, which is really nice because it organizes your work. But then there's also a method where it's just a big X. And up here on top, you always multiply when you're factoring. A, which in this case is a what? Let me color coordinate. What is the understood A right there? A 1. You multiply A times C, and you put it in the top of the X, and then you copy BX in the bottom. So watch. A times C, 1x squared, or 1 times 6 is 6. Copy BX, negative 7x. And now it's a guess and check game. What multiplies to give me 6 and adds to give me negative 7x? Negative 6 and negative 1, double check it. Multiply to give me positive 6, good. Add to give me negative 7, good. So that's your two numbers. Order does not matter here. The order of them doesn't matter. It will change. If yours is the reverse, your GCF will be different along the way, but your final answer will be the same. And you can put the X's here if you want, because that's what's fixing to go right here. So watch. Negative 7x is getting replaced with negative 6x minus x. Y'all see that? Now, the rest of it's got to come down. I haven't done anything else. All of the other stuff's got to come down. The front comes down. The back comes down. You see on that? You've just successfully written the 3 terms into 4. Y'all see it? So we are at this point in the process. We're here. All right, now we're going to group and pull GCFs out. Now this is where it gets, you got to watch your writing. If you're one of those that this is already getting messy, then just work on this in the next line. But just remember to bring the 3 down at the very end if you want to do that. And in fact, I'll show you an example. I'll do that here so you can see what I'm talking about. So I don't want to deal with this 3 anymore. I'm just going to draw an arrow and I'm going to put it down here and I'm going to put parentheses because I know that's my goal, right? All right, so now I'm going to come back here and say, okay, factor by grouping. Always group the first 2 and the last 2. And when you group right here, that should touch because that sign here is important. So always put the back-to-back parentheses touching. Now, what is the GCF in this group? X. So write it. X parentheses. What would be left? X minus 6. When I say what would be left, if it's difficult to write what's left, then come up with something and then check it by going in reverse and multiplying. If I multiply X into this parentheses, do I get what I came from? Yes, then you know you're doing it right. Repeat. By the way, that sign always, 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 always goes right there. every time. I love when something is an every time, and that's an every time. Whatever that sign is goes there. Now, what do they have in common? It's not a trick. They don't have anything in common but 1. So you're going to pull a negative 1 out. Divide everything by negative 1. And what do you notice? They match. They were supposed to. If they don't match, there should be a red flag going off like, something's wrong. They have to match. And then now I want you to visualize if I could pick these yellow blocks up and pull it forward. This is the GCF. I would pull it to the front like a multiplication, like I'm factoring it out, right? And what's left? X minus 1. X minus 1 is left. And then, of course, the 3 has to be there too, or your answer is wrong if you don't have the 3. Now, how many of you would you say is the first time you've seen that? Have you had algebra 2?
Yes. No, I did this.
Yeah, that's just how we did it at all.
Well, so you've, not any of it, so you've seen factoring.
Not like that. Not at all like that.
Did you factor it?
Yeah,
Can I see your
got the
paper?
same answer.
Did you go straight from factors of 6 that add up to, did you go straight from this to this?
No, I didn't go straight to it. I used the box method.
You went the box method, okay. The box method organizes it instead of having it in a linear fashion. It goes in the boxes and you factor the GCFs out, which is fine. You're not going to see me do it that way. So if you're okay with that.
That's fine.
You just won't see me do it.
I can kind of. I think I get it. I don't know.
There's nothing wrong with the box method. I just don't throw the box method away. I go. This helps you organize it, and then you write it out in a linear. Yes.
I know about the X, I guess. Like, I know.
That's just where you kind of organize. That's the fraction method, and that's fine. Right? Did you? Oh wait. Oh yeah. So I used to say A times C, and I'd write it like that, and I'd say it has to add up to B. I used to do that too. It was when I got freshman last year. I was like, I don't know why they couldn't write this.
But is it okay for
Yeah, it's fine. So then I found this method that kind of helps them organize their work, and that's why I started using that method. And that's fine. Number 3. Actually, no, let's go to number 1. Number 1 is called difference of squares. And that's because there's only 2 terms, and both terms are perfect squares, and there's a subtraction sign in the middle. I don't have a lot of room, so you need to write this somewhere where you've got room. For a difference of squares, it's 2 terms, both perfect. And here's the kicker, the must-have. Subtraction in the middle. That's with difference of squares. So remember, squares are when you take something and multiply it by itself. So like 81 is a perfect square because it came from 9 times 9. X squared is a perfect square because it came from x times x. So the difference of squares, I'm going to show you the long way and the shortcut. Here's where I need you to learn the shortcut. It will make your life so much easier, okay? Just know when to use it. The long way would be to recognize that that middle term is missing. And then to think to yourself, okay, A times C, right? a times c, add up to 0. What would it be? What two numbers? It would be positive 9 and negative 9, right? Then we'll throw the x there because it goes to that. So this would be positive 9x, negative 9x. Bring the front down. I'm showing you the long way. I don't want you to go this way. If you can graduate from it. What's the GCF here? What's left? What's the GCF here? What's left? What's the new GCF? What's left? There you go. Okay, that's the long way. The short way is one step. Here it is. We'll put it in blue. This is the shortcut that you need to learn. It makes your life so much easier. You have to know when you have a difference of squares to know you can use this shortcut. First, always check for any type of GCF, and there's not one. The shortcut is you know that that is going to factor to a binomial and a binomial. And you also know that it's going to be a difference of squares, right? They're going to be identical, but there's one small difference, and that's the sign. Okay, so the way you get it is you square root the first term, you square root the second term, and it's plus, minus. That's how you get the shortcut. Or it could be minus plus. Order doesn't matter on the signs. But that's the shortcut every time. So, for example, 4x squared minus 6, no, that's 40, 25. Like I didn't want to write right there. 4x squared minus 25. Every single thing does have to be perfect. Let's say that that 25 was actually a, stop it. Say it was like a 20, 23. Then you can't do anything. That would be done. Because it's two terms, it's not three. It's two terms. Yeah, that's perfect, perfect, not perfect. Okay, so every single thing has to be perfect. Also, if that was a plus, can't go anywhere. Can't do anything. Gotta learn when to recognize that. Has to be a minus. Okay, so we're good to go. Difference of squares. Write your binomials. Now, square root. I gotta get away from this little section of the board. Square root, and then plus, minus. Because when you multiply it back out at the very end, right, last times last would end up being a negative. But because they're a difference of squares, one's positive, one's negative, every time you multiply that, you get a negative. So that's why. All right, let's do number 3. Coffee bar is closed today. Y'all. But I don't care because I've got mine. Sorry, that was really mean. I hope y'all get coffee somewhere. Look at number 3. Does it have a GCF? No. Multiply a times c. You get 20x squared. 20x squared, you can write that x squared there if you want. And then copy bx to the bottom. Alright, it's got to multiply to give me 20x squared and add to give me 9x. 5 and 4 or 4 and 5, right? Check it before you wreck it. So we're going to rewrite this middle term here as 4x and 5x. And I'm going to bring the front down and the back down. And now I'm ready to group. pulling GCFs. What's the GCF here? 2x. Divide 2x away. So imagine coming under it and writing divided by 2x, divided by 2x. You would be left with x plus 2. And then multiply it back in your head real quick to confirm you had it right. Repeat. What's the GCF here? 5. If you write this, it's going to make writing your binomial challenging if you don't realize that there's a plus sign in front of that 5. So try to always copy that sign so that you will have that plus sign. And then if you divide, you have the same binomials in the parentheses. That is now your GCF. You're going to pick it up and pull it to the front like a factoring of that GCF. And then you're going to write what's left. And no, order does not matter there. If you wrote 2x plus 5 and then x plus 2, that's the same answer. Multiplication is commutative, as you learned in middle school. Order does not matter when you're multiplying. Okay, the last one. I'm running out of room. This is a perfect cube. We will have some cube polynomials. You will need to get comfortable with the first couple of cubic numbers. Cubes come from a number times itself. So 1 cubed is 1, which kind of seems irrelevant, but had that said x cubed plus 1, then you would still be able to do this. 2 cubed is 8. 3 cubed is 27. 4 cubed, 64, and I think we go one more. 5 cubed, 125. No, wait, I might have seen 216. 6 cubed, is that 216? I think I've seen 216. Anyways, those are the first couple of cubic numbers that you need to get familiar with. Be able to recognize them. So 1, 8, 27, 64, 125, 216. Those are the first 6 cubes. Now, the method for factoring cubes. I'm gonna write the answer, then we're gonna go to notebook paper, and we're gonna take actual notes, because I don't have enough room to put the notes right here, okay? I gotta refresh my memory. Let's see. It's a binomial times a trinomial. Is it double for it? I think it's 2 minus 2x. It's 2, it's multiplying together. Is this an A? What's the matter with this is so annoying. Alright, hold on, let me refresh.
You got it. You didn't. You kept going. So you said just.
Yeah. That's the answer. Now go to notebook paper. You can put the title in the notes, factory, and then I will give you some notes on it. So this serves as a couple of notes as well. Now I'm going to give you some actual notes on factoring. Okay, in the textbook, if you need to reference it, we are in just in time review number 4. And you'll notice I did make the pen less bold so that I can remove right. You'll see that? Am I writing too small?
Yeah, we do this with black lights.
Yeah. Let me fix this first. Oh my. Oh, you know what? Let's do this. You see it?
Indeed, I read.
Okay. Just in time review, number 4, factoring. Let's address cubes. Oh, I'm getting fancy.
See, how do people write about this? I'm not doing that.
Hold on. I will write on it, don't worry. I had to get a little fancy here. It's just the word cubes. I can see it. Can y'all not see it?
I can see it. I just don't know how you do that.
I used to be in the I'm actually a really good drawer and typography. Right? Not topography, typography, writing. Okay, anyways, cubes. Let's list them. Once again, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. You could keep going if you want. We'll put dot, dot, dot. But anyways, those are the first, what did we say, 6. I have 343 written. That would be 7 cubed. I guess maybe at some point I throw a 343 in there. 343. Now above it you could write that that's 1, that's 2, 3, 4, 5, 6, 7. If you need to remember. Your calculator does have a cube feature. And we are kind of getting to the point where you're going to get a calculator pretty much every day. Maybe not necessarily today. So let me show you. You might want to take these notes on your paper. Just write calculator or calc. It is the math button, and then it's number 4. You will notice says little superscript 3, and then the square root symbol. That means cube root. Number 4 says a superscript 3 and then a square root symbol. That means cube root, let's say 343. And you'll see that it will evaluate it for you. Okay? So make note that in the calculator, you're going to hit math, and then it's number 4, it says cube root. Then hit enter. And then of course you type whatever you're checking to see if it's a cube. Okay. There are 2 cases when factoring cubes. You don't have to memorize these names because when I show you the shortcut with factoring, which would be it's probably going to be on the next slide unless I can fit it in on this one. It doesn't matter which scenario it is, you'll always get the right answer. So one scenario is a sum of 2 cubes. And it looks like x cubed plus y cubed. Now, x and y here are in place of numbers or variables. They're just saying that the first term is a cube, then you have a plus sign, and then the second term is a cube. it will factor to a binomial every time. I'm going to abbreviate a binomial times a trinomial every time. Every single time. And here's how you get it. You take the cube root of the first term. So the cube root of x cubed would be x. And you write it here. First in the binomial. You take the cube root of the second term. You write it second in the binomial, or last. So this is what almost looks like a direct reflection of that cube, right? Then to get this one, think of there's more here, so there's a little more involved. You take these two terms that you just found and you square them, and they go in corresponding positions. X is in the front, x squared goes in the front. Y is in the end, y squared goes at the end. To get the middle term, you multiply these two together. So in the middle it would be xy. Now I'm changing colors for this part. You might be like, this all we have to put a single sign in there. That's because this is where you have to remember, always wash with soap. You might be like, what in the world? Soap. Same sign as what you saw in the beginning. Opposite sign, always positive. So, and we're going to write that. I'm going to write it. Actually, I'll just go ahead and write it. I'm going to leave room because we have another scenario here. So I'm going to skip some space. And I'm going to write so. Same sign. I'm referring to the one in the problem. Then you have the opposite sign. Then you have always positive. It's the last sign. Those two kind of go together. Always positive. They're saying that that last part should always be positive. All right, let me show you the other type of cube. It's called a difference. Difference of two cubes. Same concept. Not trying to be funny. One difference. It's the sign in the middle. Which means the factoring is all the same. It's just when you apply the soap rule that you'll end up with different signs. So it's going to factor to a binomial and a trinomial. Here I am showing another example. To get the binomial, you cube root both of these terms. And then now that binomial is going to generate the trinomial by squaring the terms and putting them in the corresponding positions and then multiplying the terms together in the middle. And then, of course, always remember wash with soap. Same sign as the problem, then the opposite sign, then always positive. And of course, when you factor a perfect cube, you can go and check it by using the distributive property. But I'll be honest, if you know for a fact that you generated it based on the shortcuts that I just showed you, you shouldn't have to check it. It should be right. Now, if you need to take notes on like how we got it, you know, that the binomial is the cube root of the terms, and then that the trinomial comes from the binomial, you know, squaring and then multiplying together. You need to do that. I'm not writing that because it's a pattern. So if you look at it, and now that we've gone over it, you should be able to look at it and see the pattern. But if you need to write that extra little, you know, I got this by cube rooting, I got this by squaring that, I got that by multiplying that together, and write that. I'm going to put some examples on the board, and now we're going to try it. And you might, you know, at the beginning of class, had I put these 6 examples on the board, you would have probably panicked and run. But now you should be able to knock them out in like 2 minutes. Everybody good with that? Okay, here come the examples. Yeah, I know. Hold on. There we go. Does this show up? Yeah. All right. There's only so many of these we can do because, like I said, we kind of stay around the first 7 perfect cubes. There's 6 examples. If you will factor them completely. No, but you're good to notice that there's an issue. Everyone had a chance to do number 1. Okay. So remember, maybe I need to help with number 1 just so we've only done 2. No, we haven't done any example. We did the 1 example. So let me help with number 1. Remember that you're looking at all of the terms to identify if they're cubes. So that means the exponents need to be divisible by 3. That's how you know it's a cube. And then the numbers, you should be familiar with your cubic numbers. So then once you decide if it's good to go, you've got a binomial and a trinomial. The binomial comes from cube rooting each part. You're going to cube root each part. So you get 2x and y. Right? Now the binomial is going to generate the trinomial. You're going to square those terms completely. 2x times 2x is 4x squared. Y times y is y squared. You get the middle term by multiplying these 2 together. So 2xy. And then, of course, so. So remember that, okay, so these terms come from cube rooting 8x. Okay, hold on, my marker's too.
I got that. I got it.
Okay. All right, so this comes from taking that first term and squaring it. this comes from taking that second term and squaring it. And then this comes from multiplying those together.
Oh, I didn't think about when this squared. Yeah, okay.
Oh, man. Oh. I gotta come up with a different way to display my seniors because I'm running out of room. Yes or no? Yeah. Because I gotta get all these. And then y'all better bring me senior announcements. No. You're good. Okay.
You just put one.
Did you get it? No, that's a great question. Number 3, when you factor number 3, just because it looks like conspicuous, what is it? 16 is 6. Number 3. Did you look at this and think, oh, that'll keep going? Maybe. Does it look like it'll keep going at first? Maybe at first glance you look at it and you think that'll keep going. Here's the nice thing about when you're factoring cubics, we won't keep going, like we're done. They don't keep going. That's the beauty of it. Like it's just know the shortcut and you're done. Easy A. Or easy check mark on that question. Oh no, go ahead and definitely square it. Did you get this for number 2? Get that? what was the trick in number 6? Did you catch it? Did you recognize you cannot factor it, like using the cube method? Did you recognize that? Good, okay. But I put it up there, which means there was something that I was looking to see if you caught it. What? What are each term divisible by? 2. There's a GCF of 2 in there that I was looking to see if you caught it. So if you divide these by 2, you get that, right? And then now you can factor the cube. The 2's along for the ride. It'll be in the very end. Let me rephrase that. It will be on the last step in the very front of your factored form, because it is relevant. It was there to start with. So you got the binomial, square them, shove them together to get the middle. Think of like you're shoving them together into the middle. You're multiplying them together, right? And then so, always, let's see, same sign, opposite side, always positive. Your practice assignment, because, so I printed, actually let me give this to you. I printed this to help with kind of a summary, like, hey, if you're practicing at home or in Flex and you forget, here's like a flow chart. There are problems on the back, and initially these are the ones I wanted you to do. IXL lets you know if you got it right or wrong or not. How about this? Your homework assignment is the 12 problems on the back. I'm going to post the final answers, not the work, the answers. Of course, with cubes, I may not post the cube answers because there's no work involved. Would y'all agree? There's no work for the cube answers. But for the ones that are not cubes, I'll post the final answers. So then that way you know if you got it right. Because I don't want you practicing wrong over and over and over. So the front's got your helpful flow chart and the back is your assignment. And I'll just post the non-cube, so the quadratics. I'll post the quadratic answers. But you have to have the work to get the 100. You know what? Let me just do some stacks. It's not working out. If you need extras, pass them back up. I'm not having good luck separating the papers.